In this video, I kind of wanted to go over some applications of what we covered in the last video about correlation coefficients. So I wanted to talk about how can we interpret correlation coefficients, and also wanted us to also talk about how we can use the best fit line to make predictions. Okay, so in the last video, we went over how to calculate the correlation coefficient using your calculator, but just a quick little recap. The correlation coefficient is a measurement of the strength of the linear relationship between some paired data, ordered pairs, so to speak. If you have positive linear correlation, that means that the general trend of your data values is that as the x value increases, the y increases as well. That's where we're getting this positive slope line from. That's where the term positive comes from. Negative correlation is the opposite of that. It's what happens as your x's increase. Now your y values are actually going down. And then zero correlation is whenever, well, you just have a slope of 0 there, which is a horizontal line, if you remember that from your algebra class. All right, we got a quick little question here. What is a good estimate for R in the following regression line? So what they have for you here is the blue squares. Those are the ordered pairs. And then the red line is the regression line, also known as the best fit line. So as we can see, the data values, ordered pairs, are really, really close to that red line. Okay. So to me, what that tells me, and look at that red line, it has a positive slope there. So what that indicates that our R should be close to a positive 1. To positive 1. Remember, your R, your correlation coefficient, can be positive or negative. But because our slope is positive there and the points are close, we're going to have a strong positive linear correlation there. Which of the following values has the weakest relationship? So, as we just saw, if your R is close to positive 1, that means you have a strong positive linear correlation. If your R is close to negative 1, that means you have a strong negative linear correlation. So the farther you're away from that negative 1 and positive 1, meaning the closer you are to 0, the weaker the correlation. So the closer you are to 0, the weaker the correlation. So as I look at these 4 different R's, the question becomes, which one is closest to 0? It's not a matter of if it's negative or positive. Which one is closest to 0? Well, the R of 0.26 will have the weakest correlation because it is the closest R to 0. Okay, so the other thing that we calculated in the previous video was the line of best fit, aka the regression line. And so what we can do is we can use that regression line to make a prediction for points that are not in that data set. It's a really cool way of making a prediction based off of some information you know from before. It's very similar to a weather forecast. What they do, they take previous data, previous models, they use that information to now predict what's going to be our high temperature tomorrow. Well, to calculate your best fit line, if you remember, the best fit line was of the form y equals, in fact, I'll put a hat on it for predictive value. It was y equals ax plus b, right? And so what's important here is that the x that you plug in, the x value that you plug in, has to be between, or has to be within the x values that were in your original data set. What I mean by that is because a best fit line is best whenever you are doing what's called interpolation. Interpolation means you are filling in the gaps within something. Okay? So whenever we interpolate, meaning we plug in an x value that's within our original data set of x values, we're going to get a value that we could be fairly confident in. However, if we go outside of that spread of our x data values, now we're doing something that's called extrapolation. And the analogy I always use for extrapolation is, Imagine if you, I don't know if you've ever seen a 30-day forecast. A 30-day forecast is absolutely horrible. Why is it? Because it goes beyond a few days. After a few days, the weather is basically unpredictable, right? So what the 30-day forecast is bad because it's extrapolating. It's going beyond the means of the capabilities of the model. Okay? So what we want to do is we want to avoid this extrapolation. And they define it as if the X value is higher or lower than all of the points in the data set, this is called extrapolation. So if your X values are more than or smaller than what you're working with in your original data set, you are extrapolating. Okay. The other thing that you want to be careful with is the reasonability of your answers. Okay. So let me go back. So interpolation versus extrapolation, that's how you determine the reliability. When you are interpolating, you will get a reliable result. Okay. However, the reasonability of the answers is because, well, reasonability means, does the answer make sense? Is it possible to get the Y value that you calculated? Okay. So I think it's just best just to jump straight to a question here. May have confused you. All right, here we go. Students, for example, students are going to take a generalized knowledge test, which is scored out of 100 points. So the maximum score you can get is 100. The regression equation generated from 1st to 12th grade students is y equals 7.5x plus 10, where x is the student's grade level and y is the score that they would likely receive. Okay, so maximum number of points is 100. The x variable in this represents a person's grade, which is between the 1st and 12th grade. So our x values have to be between 1 and 12. Okay, here we go. Question 1. What is the predicted score of a 3rd grader? Well, we know that our best fit line, so this is equation 1, is y equals 7.5x plus 10, where y is the student's grade and x is their grade level. Well, to figure out the score of a 3rd grader, all we have to do is plug in 3 for x. So y equals 7.5 times 3 plus 10. Let's see what that equals. 7.5 times 3 plus 10 gives us 32.5. Okay, so y equals 32.5. Okay, so we are anticipating a score of 32.5 for a 3rd grader. Okay, so the question is this: that 32.5, is this answer reliable and is it reasonable? Those are two separate questions. Let's talk about reliability. Reliability comes from what value of x did you plug in, and is that x within the spread of your original data set? For this problem, number 1, we plugged in an x value of 3. We're working with a 3rd grader. And they told us that our x's go between 1 and 12. So what that means is that we are interpolating, which is a good thing. So this answer is reliable. It is reliable because we are plugging in an x value that is between 1 and 12. If we had to plug in a 0, let's say, or 15, then that no longer becomes reliable. Now we are extrapolating, which is no bueno. Reasonable. Is our answer reasonable? Well, to answer this question, you ask yourself, is it possible for a student to score 32.5 on a test? Yes, it is possible. So reasonable means, can you obtain that score? Yeah, somebody could get a 32.5. It's not a great score, but it's possible. Is it possible for somebody to score a negative 20? So if you plug in your x value, you end up with, in this scenario, a negative number. It doesn't make sense in the context of our problem. And in that case, your answer would not be reasonable. Or if a person scored more than 100, they can't score more than 100 on this test. Let's look at the second one. Maybe this will clear it up for you. The second question says, what is the predicted score of a post-grad student? That's a person that's in the 18th grade, so to speak. Let's calculate their grade. So that means y is 7.5x plus 10. It's the same best fit line. And we're going to now plug in 18 for x, add 10 to it. Let's see. So that's 7.5 times 18 plus 10. That gives us a score of 145. So let's go back. So we get a score of 145. Okay. Same two questions. This answer we got here, the score of 145. The question becomes, is it reliable? Is it reliable? Well, remember, reliability means, are you plugging in an x value that's between the original data values? Our x's need to go between 1 and 12, but we plugged in an 18. That is outside of our data set, which means we are extrapolating, which means the answer is not reliable because we plugged in a number that's not between 1 and 12. Is our answer reasonable? Okay, well, this goes back to the fact that if this person was in 18th grade, based off our model, they're saying they could score 145. Well, is it possible to score 145 on a test that has a max of 100? You can only score 100 as a maximum score in this. So in this case, 145 is not reasonable because you cannot score 145. And what this illustrates is the dangers of extrapolating, of going too far with your model. You must always be cognizant of what your model can and cannot tell you. All right, see you guys in the next video.